morning, everyone. Andy. So, online students, can you hear my voice? Say yes or no to me once. So, the last class notes not available with you. Two minutes. Right. So, the last class I started Friday, threading concept I planned for Saturday and today, but one day missed. Let me repeat what has been happened. The set of programs which are collected together to perform defined action is known as application. A set of programs collected together to perform defined action is known as application. According to Java developer, application under execution is a process. So according to Java developer, the application under execution, the meaning whenever we want to execute, we execute the application. We call the application, we execute the application. It's a theory. Now, define task. The part of process is known as task. So in this application, each program is one task actually. Each program is one task. So each program will be one task actually. The part of process is known as a task. Here, application means process. Process has 5 parts. Each part is one task. It's a theory. According to Java developer, each program in application is a task. Simply you can say each program in application is a servlet program. The meaning is servlet program means a task. It's a meaning. Now finally here I stopped by one definition. Define multitasking. Define multitasking. Executing multiple tasks simultaneously. Executing multiple tasks simultaneously is known as multitasking. Is known as multitasking process. Executing multiple tasks simultaneously. Underline the term simultaneously. Simultaneously. Simultaneously means at a time but not parallel. At a time but not parallel. Simultaneously means at a time but not parallel. But not parallel. Look here. Simultaneously means at a time, not parallel. The meaning is, suppose there are some tasks. There are some tasks. So at a time meaning is nothing but both will take the request. Both tasks will take the request. Both tasks will give the response. But they are not parallel. They are one after the other. They are not parallel. Parallel means, example, how I can say, you are attending Oracle class and Java class. They are not parallel. Parallel means now you are in Java but not in Oracle. After Java you will be in Oracle. After Oracle you will be in Java. But parallelly not possible. You cannot sit in Java and Oracle parallelly. Not possible. Now these two executions parallelly not possible. But at a time. At a time meaning is nothing but the output time will be same. Both will come inside, both will go outside. Means what? Suppose Oracle take 3 months, Java takes 3 months, roughly. So one after the other means 6 months, roughly. But here 2 components output time is 3 months only. But internally you are not attending parallel, you are attending one after the other time at a time. Both will come inside, both will go outside at a time. But internal execution is not parallel. Both will get the request at a time. Means with millisecond time, both will get the output. But not parallel. It is simultaneous. That only concept. All your web browsers in the market, www.irctc.co.in, requested by 5 users, all will get the result at a time, but internally not parallel. Small millisecond time difference is there between each user where we cannot identify. The best example, open VLC player, type in the notepad. You feel that both are happening parallelly. You feel that I am listening songs, I am typing in the notepad. Both are parallel. You will feel it. But they are not parallel. They are at a time and simultaneous. Internal execution is not parallel. That only meaning. That only your others will call it as a simultaneous, concurrent, at a time they'll say. They never say parallel. Parallel means both you have to pick at a time. Not possible. That only I'm saying it. Multitasking also. Executing multiple tasks simultaneously, but not parallel. That's the meaning of it. Now, in this program now, both users, user 1, user 2, both users requested user app, both opened user app. One user is performing registration. One user is performing login process. One user is performing registration. One user is performing login process. Now both has to get the response. Both has to get the response. Internally, this must be executed. This must be executed. Only concept. Now both are executed. Both are executed simultaneously. That only multitask. But how it happens means, suppose example I'll say, 5 students are waiting for me outside. They are waiting out of the door. My loader will ask, why you are standing here? We want to meet Venkatesh sir to correct our notebooks. Each notebook contains 5 papers. So 5, 5, 5, 5, 5. All are having 5 papers to be corrected by me. I am the executor. Okay, right? My loader will ask me, sir, there are 5 students standing outside. They are waiting you to correct their notebooks. How I should load them? I'll say, load one after the other. I said, load one after the other. Now, first student will come for me. Means executor will come. Now when the first student came here, these 4 students are waiting. Now I took 5 minutes time to correct this notebook of S1. After 5 minutes, S1 went away. S2 came. S2 came after 5 minutes. Right? He leaves after 10 minutes. Better or now? Right. Now S3 will come after 10 minutes. See, waiting time is increasing now. Here 5 minutes, here 10 minutes, here 15 minutes, here 20 minutes. So waiting time will be increased. Suppose if we do this kind of process in real time, suppose 10 users are trying to book the ticket. www.irctc.co.in. If I follow this process, what happened now? User 1 has to complete the total work. Then user 2 will get the access. User 2 has to complete the total work. Then user 3 will get. We don't know the user 5 will get after how many minutes. We cannot predict. So this kind of execution is failure. Because in online mode, lakhs of users will be connected. That users in the last user, he waits for 24 hours or 3 days to access to the server. This mode is failure mode, not available. Then my loader will ask, sir, this loading is failure mode loading. Is there any other process? Then I'll say, send all the students to me. S1, S2, S3, S4, S5. All students are with executor. Now I'll ask all the students to open the page number 1. I corrected page number 1, S1, page number 2, S1, page number 3, S1, page number 1, S3, page number 1, S4, page number 1, S5. Means what? I done some part here, some part here, some part here, some part here, some part here. So what is the waiting time now? Sir, this is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. This response time decreased, no? So internally what happened now? I am not correcting 2 books at a time. I am doing simultaneously, not parallel. But output is what happened now. I'll do again second page, second page, second page, second page, second page, third, 4. At least with milliseconds of the time, all will go out, all will come inside. This is multitask. All are getting the responses, no maximum waiting time. The same process happens in the real time. Now when the user 1 comes, user 2 comes, we are correcting 1 page here, means some part we are doing. Here also we do some part. Only some part is executed here. Only some part is executed here. Only some part is executed here. After that again, some part is executed here. Again, some part is executed here. Some part there, some part here. It is doing some part, some part, some part. So, whatever the part executed here, whatever the part executed here, this part, we call it as thread. That among the task, one part executed, that part we are calling it as a thread. So, that process we are calling it as thread-based multitasking. Make it FAQ. Thread-based multitasking. Define thread-based multitasking. Thread-based multitasking. Executing multiple tasks from the same process. Nothing but same application. Executing multiple tasks from the same process is known as executing multiple tasks from the same process simultaneously is known as thread-based multitask. Executing multiple tasks from the same process simultaneously is known as thread-based multitasking. So here, define thread. Define thread. So from that diagram, what we observe now? Sir, the part of task. The part of task is known as thread. The part of task is known as thread. Underline the term part of task. Part of task is known as thread, and which is lightweight and background process, and which is lightweight and background process. Lightweight and background process. Lightweight and background process. Underline lightweight and background process. Right. Sir, lightweight means what? Look here. Lightweight means consumes less execution time. Executing task will take more time. Here task is 5 papers is a task by each student. If I execute the total task, I'll take 5 minutes. If I execute part of task, I'll take 1 minute. Execution time is decreasing, no? The part of task is known as thread. So, executing the part of task will consume very less time. Part of task will consume very less time. So that one, your other want to say to you, he said lightweight process. Lightweight execution means very small execution. Lightweight means execution time is very, very, very less. Make it. Lightweight means consumes less execution time. Consumes less execution time. Consumes less execution time. Background. Sir, background process means what? Sir, background process means what? Background process means what? Look here. Here, name of the application is user app. Name of the application is user app. Name of the task is register. Name of part of task is not there. Name of part of task is not there because it is background process. It is a background process. Moreover, without owning the parent process, this thread will not run. You cannot on the thread directly. You must on the parent process. Then only the child process will run. So, thread other name is child process. The best example, Microsoft Word. Everybody knows. Microsoft Word is a parent process. Whenever I am typing something in a Microsoft Word, whenever I make a mistake, spelling mistake, one line will come down. One line will come down. Means what? Spell check is running in the background. We say the spell check is a background process. Without owning Microsoft Word, you cannot on spell check. Because of this reason, spell check is a background process. Here also, without owning user app, you cannot register. Without selecting registration, the part of task is not executed. So it is a background process. Lightweight and background process. That is the name given. So background process means there is no separate identification. It is identified by its parent process. Make it. Background process means there is no separate identification. There is no separate identification. That is background process. This thread is also known as lightweight process. Also known as child process. Other name is child process. Known as child process. You can say lightweight process. You can say background process. You can say child process. So these many names available for the thread. Now, define multi-threading. Define multi-threading process. Define multi-threading process. Executing multiple threads simultaneously. Executing multiple threads simultaneously is known as multi-threading process. Multi-threading process. Executing multiple threads simultaneously is known as multi-threading process. Multi-threading process. Now, to explain this multi-threading, let us execute multiple threads. Means multiple parts of task simultaneously. Executing multiple parts of task or multiple parts of multiple tasks. Right? Simultaneously we call it as a thread anyway. So for theoretical, this diagram will be pasted there. So these are our reading definitions anyway. Now, let us create thread. Star mark IMP, creating and executing thread. Creating and executing thread. Creating and executing thread. Step 1. So whenever you want to construct one thread, so write one program. Program means a class anyway. I want to convert this program into thread program. Then the class must be implemented from one built-in interface known as runnable. One interface is there, runnable, that should be linked. So the first step is the user defined class must be implemented from java.lang.runnable. One interface is there, you should link it. When you link this, then your program will be converted into thread program. After now your programs are non-thread programs. Now you are converting your program into thread program. Make it. The user defined class. The user defined class must be implemented from java.lang.runnable interface. Runnable interface. The user defined class must be implemented from java.lang.runnable interface. I want to see the structure of runnable. I want to see the structure of runnable. This is runnable. This is runnable one interface. This runnable interface is holding one method run. Draw one box and keep it. Right. Right. Look here. I will take one application name here for demo purpose. For demo purpose, I am taking one application. thread app one application. Nothing but project application. Inside this, I had one package. So don't see the package, see the programs. 2 programs are there. So imagine it, 2 programs. This is one application, 2 programs. Display one program. Display 2, one program. Sir, one program is one task. This is one task 1. This is one task 2. So each program is one task. Now, display 1, display 2, 2 programs. Now, our rule is what now? The user-defined classes must be implemented from runnable. So, these classes are linked to runnable. Runnable one interface. This runnable interface is linked here. So these are implemented from runnable. Runnable is having one method. That method is abstract. So what is the rule of interface now? Sir, the implementation classes has to take the method from interface and construct the body. Yes or no? Now, these 2 display methods will take the method from there. Void run, one method. Here, it takes the method. In this run method, here, print 1 to 5. So print 1 to 5. The body printing 1 to 5. This body is printing 105. Roughly 101 to 105. So this body different, this body different. The bodies are different. So the 2 programs here also same only. In this diagram, the first diagram, this one. Register, login. Example for us, display 1, display 2. This is one task, this is one task. Here also, this is one task, this is one task. This is one task and this is one task. Now, this is the first step. The user-defined classes must be implemented from runnable. Step 2. Once it is implemented, these user-defined classes, which means implementation classes, must construct the body for run method. Must construct the body for run method. These user-defined classes, which means implementation classes, must construct the body for run method. Must construct the body for run method. Anyway, we are constructing the body for run method. Here separate body, here separate body. Next what, sir? We have to call the methods, no? That only our coding actually. But here in threading process, you must not call that run method directly. We must call the run method by using another method. That is start method. So we have to call the run method by using start method. That is the rule of multi-threading. Sir, why we have to call with start method? Because threading algorithm should be activated. The thread algorithm is available in the start method. The start method is a built-in method. But whenever I want to access start method is not available in the run method. Start method is not available in the run method. But I want a start method. The start method is available in another class known as thread. One more class known as thread. In this thread method, we had a method known as, in this thread class, we had a method known as start. So we have to bring this start method for execution. Whenever I want to access start method, we have to create object for thread class. So before that, step 3, make it. Step 3. Create object for user defined classes. Create object for user defined classes. Create object for user defined classes. After creating object for user defined classes, step 1. Create object for java.lang.thread class. Create object for java.lang.thread class and while object creation pass user defined class object reference as parameter. Create object for java.lang.thread class and while object creation pass User defined class object reference as parameter. Note. What is the meaning of this point, sir? Which means thread class objects will hold the references of user defined classes. So thread class objects will hold the references of user defined classes. So these 2 points I have to explain to you a bit clearly. Of writing the program, I'll draw one small diagram. Which object will hold reference of which object? And only major. If you understand that, finish. Thread creation is over. Okay, right. These 2 points I'll explain. Okay, right. The 5th point. Step. What I said just now, sir, we have to call run method by using start method. After these 2 steps, start method is available. So call run method for execution using start method. Call run method for execution using start method. So this process you have to remember it for interview. If anybody asked how you will create a thread means, you must explain that 5-step process. Then the thread is created. 5-step process, then the thread is created. Now I'll follow this. Let me write the program. Whether thread execution is happening or not. Thread application 1. Right click SRC, new, take one package test. Display 1, click on finish. Display 2. Here. Implements from runnable. Implements from runnable. So whenever it is implemented from interface, it has to construct the body for void run. So public void run. Now inside this run method, I am writing one for loop. int I is equal to 1, I less than or equal to 5, I plus plus. I am printing 1 to 5. Task 1. Just I am keeping one message, println task 1. So we want to see this output bit slowly. For that, I will write one try catch. Thread dot sleep. I introduced this sleep method in your exception handling chapter. E dot print stack trace. So sleep method will stop the execution temporarily on some timer to see this output now. Finally, run method is having a body printing 1 to 5. It's a concept. Now display 2. Here body 101 to 105. This is task 2 to see that output. Now 2 implementation classes are ready. 2 implementation classes are ready. Now create object. See there, first 2 steps implemented from runnable, constructing body for run over. Now create object for user defined classes. Go for main class. Demo thread 1. Here import test.start. Create objects for user defined classes. Display 1 ob1 is equal to new display 1. Display 2 ob2 is equal to new display 2, like this. So creating object for user defined classes. Now create object for thread class, step 4. Thread T1 is equal to new thread. Thread T2 is equal to new thread. Sir, why you are creating 2 objects here? Because 2 user defined class objects. I made one statement now. While object creation, pass user defined class object reference as parameter. Means what? Here OB1 as parameter. Here OB2 as parameter. If I pass OB1, OB2 as parameter, now thread class object holding reference of user defined class object. So once these steps, step 3, step 4 completed, step 5, call run method for execution using start method. So we are calling T1 dot start, T2 dot start. T1 dot start, T2 dot start. See there, all of you. If I execute this program now, if I execute this program, 2 tasks will run simultaneously. two tasks. This task should run simultaneously. It is shifting here and there anyway. Sir, which one it is starting means algorithm will start by its own. It can start from there or it can start from here. It can start with task 2 or it can start with task 1. But running simultaneously, some task 2 some part, task 1 some part, task 2 some part, task 1 some part, task 2 some part, task 1. If not, I'll start with means one algorithm will be there in the background. It only will start it. So this is the program actually. So I took display1.java. I took display2.java. I took demo thread1.java as a main class. Here I'll paste that diagram. Whatever I drawn, then I'll paste it. Sir, I want to know which object holding, which are two programs are running simultaneously. Display 1, display 2, both are running simultaneously. Display 1 answer is coming, display 2 answer is coming, both are coming. Task 2, task 1, task 2, task 1. Task 2 means this one. How it is running now, sir? Some part it is running from here. Some part it is running from here. After that, some part it is running from here. Again, it is running some part from here. Again, it is running some part from here. So what you observed here, it is executing part by part like this. Because the answer is coming 101, 1, 102, 2, like this. Part by part it is executing. So this program is a demo program to you. In real time, your servers are there, no Tomcat server and so on. So Tomcat server everybody knows normally. So whenever you deploy your application to Tomcat, the Tomcat will do all this work. Linking to runnable. Each servlet is one thread. Whenever you load the servlet, automatically one object created. Execution starts like a multi-threading process. The theory. Now, sir, I want to know more clearly what has been happened. Small flow. I want to know which object holding the reference of which object. Sir, execution flow of above program. Execution flow of above program. Here how many class files are there? Means 3 class files are there. Display 1 dot class file. Display 2 dot class file. Demo thread 1 dot class file. This is main class. Now look here. Execution starts from main method and main class. From day one onwards, we draw method area, heap area, Java stack area, and so on. When the thread comes here, we have to imagine it. Java stack area. In this Java stack area, first main stack is created. First time I am using a word as main stack. I am using a word known as main stack. I am using. Actually, Java stack area is a collection of stacks. Main stack will be there, thread stacks will be there actually. From day one onwards, I am drawing main stack only. Now I am drawing the thread stack. So in the main stack here, main method will come. Sorry, into the main stack, main method will come. In this main method now, what is the first program? First one now, OB1 and OB2. First one is OB1. Sir, object creation. First one is one object creation. One object creation. One object is created. This object will hold one run method. Run method. Printing from 1 to 5. It's a run method. So OB1 object created. After OB1 object created here, OB2. Second object is OB2. OB2. In this OB2 also, one run method is there. One not 1 to 105. So two objects are ready. OB2 object is ready. Now we are creating two objects. Thread 1 and thread 2. I am creating thread 1. I am creating thread 1. I am creating thread 1. So whenever I am creating thread 1 here, (0x33). Now thread 1 object will hold reference of OB1, means the address is binded here. All of you understood this? Say yes or no to me, right? To make you to understand this only, references concept is there. In the references concept, employee object will hold reference of address object. We had a syntax. The same way, thread object is holding reference of display object. Thread class will have start method. Thread class will have start method. The start method will come there. So that is T1. The same way I am creating object for thread 2. Now this is thread 2. (0x44). I am passing OB2 as parameter. Here 0x22. Here the start method will come. So this is T2. So these are the objects. Because I made a statement down here, which means thread class objects will hold the references of user defined class objects. Sir, what is the advantage now? Now start method can use this run method. The start method can use this run method. Not only references concept. The method of one object can use the members of another object through address locations. Now we are having here T1 dot start. We are calling a start method. We are calling start method. So whenever I call T1 dot start, I am calling T1 dot start. I am calling. Now this start method, I called it. Now that start method will come for execution actually. The start method is a built-in method. In that built-in method, already logic is there. The logic is a thread logic. Some algorithms are there activated. Now the start method will do one work. Start method will ask the execution control to create one separate stack. Separate stack is created here. We call it as thread stack. Separate stack is created. Thread stack for T1. Separate stack. After creating the separate stack now, the start method will use this address. After using this address, control will come here. After control came here now, this run method is copied here. Separate stack. The run method is copied here. The run method will come here. This run method will come for execution. Start method duty is to create separate thread stack and load the run method. That's called starting. I will start it. That's the meaning actually. Now the start method destroys, the run method came here. Now immediately T2 dot start. T2 dot start. This also executed. Now this T2 dot start, again start method, no? Right. The start method means separate stack is created. When the start method comes, separate stack is created. This is thread stack T2. Now that start method, the start method will use this address, will come here and load that run method onto separate stack. Method onto separate stack. Now, one run method came from display 1. One run method came from display 2. This is 1012, 105 logic. And this is 125 logic. Actually, one is registration, one is login. I cannot do that, no? Just I am taking display 1, display 2. Now, the thread algorithm will execute both. It will ask the execution control to execute some part from here. The execution control means the thread scheduler will start with 1 or 2, anything. So, internally it runs one algorithm. So, based on its flexible, it starts with 1, it starts with 2. Means internal response times, who came first, who came last. It calculates some concepts and it runs. So we are imagining the output. Some part is coming from here. And some part is coming from here. That's output coming already. Some part is coming from here. Some part is coming from here. So once that the two methods are, that's called simultaneous, executing multiple tasks simultaneously is known as multitasking. Executing multiple tasks from the same application, thread-based multitasking. And at a time we are executing only part of task. Here task means one. Printing 1 to 5 is one task. Printing 101 to 105 is one task. But we are not executing the total task. First we are printing 1. Then we are printing 101 from another. Again you are coming back and printing 2. Means you are doing some part only, no. That some part we call it as a thread. That's a concept. That's called thread-based multitasking. That's a concept. You are executing one thread here, one thread here, one thread here, one thread here. Means thread means part of task now. You are executing one part from here, one part from here. That's called multi-threading flower. It's a theory. So this is the view of your multi-threading anyway. Executing multiple threads. So remaining process same. When the execution ended, this will be destroyed. This will be destroyed. Once these two are ended, main also ended. This is destroyed. Total, the stack is destroyed. All of you got this concept now, right? So start method only will do the work. Sir, if I don't call start method, see the output. Sir, T1 dot run method. T2 dot run method. I am not calling start method. If we don't call start method, actually, if we don't call start method, These concepts are not there. Daily you are drawing one diagram, no? Main will come. Upon that main, one run will come, execute, destroyed. Another run will come, execute, destroy, that like this. So it is like a normal execution, it happens. Executing normally or not now? It is not a threading flavor, it is a normal program flavor. If we use start method only, algorithm will come. So who written algorithm now? Sir, service engineer never writes. Already available, we are using. By calling that start method, we are using. That's a theory. So start method is mandatory here. T1 dot start. T2 dot start. Run it. There is no specific reason why it is starting with 2. It can start with 1, it can start with 2, because internal thread schedulers will use one algorithm, time slicing algorithm. They'll give some part here, some part here, some part here, some part here, like this. So want to run it. Now, this is the program for today, creating thread anyway. Now, you know, sir, when interface implementation is there, you can convert this program into anonymous, no? Yes or no, na? You can write implementation class without name, you can write, no? Right. You can write lambda expression, no? So, latest one is lambda. This is old one. This code is not available in the market. This code is to make a student to understand what is thread flavor. But speak in the interview, how you'll create thread means 5-step process. It is a basic process. But at the last, add one point. In real time, this process we do with lambda expression. That is the latest. Before lambda, who is there now? Anonymous is there. Right? Okay. Now I'll copy this program to you. I'll add the diagram to you. Notes is available. So assignment is convert the above program into anonymous and lambda. Tomorrow, first 10-15 minutes, I'll convert it. Right? After conversion, thread synchronization, one concept is that. Thread synchronization means if multiple threads come to the same one, how to organize. That is the last concept. Okay, right. Tomorrow we shall close it. Actually, the plan I made like this: Saturday, today, multi-threading. Tomorrow, conclusion I made it. Right. So tomorrow, completing threading, and after tomorrow, conclusion. Right. Okay, that's the plan. Right. I'll add this. You try and come today. I'll add this diagram here. Assignment. Assignment. Convert above program into anonymous inner classes model and LAMBDA lambda expression. So try this model and come tomorrow. Okay. Thank you very much for today. Take a break. So 2 notes is Friday notes, today's notes. I'll add it. చేయలేదు
అంటే మీరు 4 hours వస్తారు